Let g of x equal 1/4 x to the fourth minus 4x to the third power plus 24x squared. For what values of x does the graph of g have an inflection point, or have a point of inflection? So let's just remind ourselves what a point of inflection is. A point of inflection is where we go from being, where we change our concavity, or you could say where our second derivative, g prime of x, switches signs. Switches signs. So let's study our second derivative. In order to study our second derivative, let's find it. So we know that g of x is equal to 1/4 x to the fourth minus 4x to the third power plus 24x squared. So given that, let's now find g prime of x. G prime of x is going to be equal to, I'm just going to apply the power rule multiple times. 4 times 1/4 is just 1. I'm not going to write the 1 down. It's going to be 1 times x to the 4 minus 1 power. So 4 to the third power minus 3 times 4 is 12. X to the 3 minus 1 power, or x to the second power, plus 2 times 24, or 48, x to the 2 minus 1, or x to the first power. I could just write that as x. So there you have it. I have our first derivative. Now we want to find our second derivative. So g prime prime of x is just the derivative of the first derivative with respect to x. And so more of the power rule, 3x squared minus 24 x to the first, or just 24x, plus 48. So let's think about where this switches signs. And this is a continuous function. It's going to be defined for all x's. So the only potential candidates of where it could switch signs are when this thing equals 0. So let's see where it equals 0. So let's set it equal to 0. 3x squared minus 24x plus 48 is equal to 0. Let's see, everything is divisible by 3, so let's divide everything by 3. So you get x squared minus 8x plus 16 is equal to 0. And let's see, can I factor this? Yeah, this would be x minus 4 times x minus 4. Or you could just view this as x minus 4 squared is equal to 0, or x minus 4 is equal to 0. Or where x equals 4. So g prime prime of 4 is equal to 0. So let's see what's happening on either side of that. Let's see if we're actually switching signs or not. So let me draw a number line here. And so this is 2, 3, 4, 5, and I could keep going. And so we know that something interesting is happening right over here. G prime prime of 4 is equal to 0. G prime prime of 4 is equal to 0. So let's think about what the second derivative is when we are less than 4. And so actually, let me just try g prime prime of 0, since that'll be easy to evaluate. G prime prime of 0, well, it's just going to be equal to 48. So when we are less than 4, our second derivative, the second derivative is greater than 0. So we're actually going to be concave upwards over this interval to the left of 4. Now let's think about to the right of 4. Just in a different color. So what about to the right of 4? And so let me just evaluate, what would be an easy thing to evaluate? Well, I could evaluate g prime of, well, why don't I do g, or the second derivative, g prime prime, I should say, of 10. So g, I'll do it right over here. Let me do it, well, I'm running a little bit out of space, so I'll just scroll down. So g prime prime of 10 is going to be equal to 3 times 10 squared. So it's 300 minus 24 times 10. So minus 240 plus 48. So let's see, this is 60. So 300 minus 240 is 60 plus 48. So this is equal to 108. So it's still positive. So on either side of 4, g prime prime of x is greater than 0. So even though the second derivative at x equals 4 is equal to 0, on either side we are concave upwards. On either side the second derivative is positive, and so And that was the only potential candidate. So there are no there are no values of x for which g has a point of inflection. X equals 4 would have been a value of x at which g had a point of inflection if the second derivative switched signs here. If it went from positive to negative or negative to positive, but it's just staying from positive to positive. So the second derivative is positive, it just touches 0 right here, and then it goes positive again. So going back to the question, for what x values does the graph of g have a point of inflection? No x values. And I'll put an exclamation mark there just for drama.